we've looked at several games or examples of games, and so far all of the games we've seen, most of the games we've seen, the players had a dominant strategy. The only ones that we showed where the players didn't have a dominant strategy were those that worked out better in a sequential game. And we've also seen that when players have a dominant strategy, then we have a Nash equilibrium, right? But there are some games, a lot of games, where neither player has a dominant strategy, and sometimes there's either no Nash equilibrium, or sometimes we have more than one Nash equilibrium. So remember that the Nash equilibrium is just an outcome under which neither player has a regret. It is possible, it is plausible that we could have an outcome or a scenario where there's more than one outcome without regrets, or where there's no outcome without regrets. So let's look at a couple of examples of games where things don't work out necessarily quite as cleanly as they have in our past examples. So here's a game, racquetball, or soccer, and PKs in soccer, if you want to think about it that way. So it's a game where the person who's hitting the ball has to either hit to the left or to the right, and the person who's defending the hit or the kick has to guess which way to go for their defense, because things are going to happen so fast. And so if the hitter hits to the left and the defender guesses to the left, then the hitter has a regret. They wish they'd gone the other way, right? If the hitter hits to the left and the defender guesses to the right, then the defender has a regret. They wish they'd gone the other way, right? And so you can go through this table, this racquetball or penalty kick scenario, and you can see that no matter where we end up, someone won and someone lost. And so the loser always is going to regret which way she went. She's going to wish she'd gone the other way. So this is a situation, this is a game where there is no Nash equilibrium. There's always a regret, regardless of the outcome. Here's another game. This is known as the Battle of the Sexes. It's not exactly a battle. So the story here is that Romeo and Juliet are madly in love with each other. They've decided that they're going to go to a restaurant together at the end of the day, but each of them has to go to class first. And they go to class at separate parts of the campus, and so after class they're going to drive separately to the restaurant. The problem is that after a long day of classes, each of them has forgotten which restaurant they chose to go to, right? So the choices are either restaurant X, which is Romeo's favorite, or restaurant Y, which is Juliet's favorite, right? So Romeo would really like it if they ended up at restaurant X together. Juliet would really like it if they ended up at restaurant Y together. So the best outcome for Romeo is restaurant X with Juliet. So each of them chooses restaurant X. The best outcome for Juliet is restaurant Y with Romeo. So each of them chooses restaurant Y. The second best option for each of them is to go to the other's favorite with them, right? So neither of them, because they really like each other, neither of them wants to go to the restaurant that the other one is not at, right? They're willing to go, so Romeo's willing to go to Juliet's favorite restaurant as long as Juliet's also there, right? So Romeo's second best option, his best option is to go to his favorite with Juliet. His second best option is to go to her favorite with her, right? The third best is that they end up at different places, but at least they're each at their favorite. And the absolute worst possible outcome is that they're at different places. Juliet chosen restaurant X and Romeo's chosen restaurant Y. They're at different restaurants and they're each at the other's favorite. So they're not even at their favorite restaurant and they're apart from each other. So that's the story behind this game table, right? So if you analyze the game and you think about each one's best strategy, For Romeo, he can say, I don't know where Juliet's going to go. I forgot. What if she goes to restaurant X? My best outcome is to also go to restaurant X. What if she goes to restaurant Y? My best outcome is to also go to restaurant Y. And Juliet's going to think the same thing. If he goes to X, I want to go to X. If he goes to Y, I want to go to Y. And so if we go through and we draw our circles here to analyze this game, we see that there actually are two Nash equilibria. Neither player has a dominant strategy, because whether Romeo wishes he had chosen X or Y depends on which one Juliet chose. There's not one best choice restaurant for Romeo or for Juliet. But if they both end up at the same restaurant, they don't have a regret. They're glad they chose the one they chose, because obviously their significant other also chose that restaurant, right? So both of them at restaurant X or both of them at restaurant Y, these are both Nash equilibria. These are no regrets scenarios. And so this is a game where nobody has a dominant strategy, but there are two Nash equilibria.